If you sequence the DNA of people living, today you can see that all people, outside of Africa, carry between 2 and 5%. Neanderthal DNA fragments. They were once painted as clumsy cave dwellers brutes, with heavy brows doomed to fade into the ice. But ancient DNA now tells a far more unsettling story. They basically are like the closest species or subspecies of us. How much? They were actually different. How much? We want to see them as different from us, how we can define being human. Neanderthals were not a simple branch that snapped off the human tree. They were part of a braided river that still runs through our veins. What if the European caveman story was never the full picture? Today we'll reveal the sharpest insights from ancient DNA that recast Neanderthal origins as a tangled, continent-spanning saga, the riddle in the bones. For centuries, the Neanderthals were treated as history's primitive footnote, a species too crude, too limited, and too doomed to matter. They were cast as Europe's cavemen, a branch of humanity that splintered off in frozen place while we evolved beyond them. Textbooks labeled them as an evolutionary mistake, creatures that belonged to the caves and vanished into extinction. But buried deep within the layers of soil and bone, something didn't fit. The fossils refused to stay silent. Their bones carried secrets that told a far more complex story, one that science was never prepared to hear. The first signs of a change in perception occurred in Europe itself. Neanderthal remains, discovered in places like Spain's limestone caves, French fields, and Croatian valleys, cried out for a reconsideration of such people as primitives at all. They were already able to control the fire to build more or less convenient houses and to make remarkably sharp and thoughtful stone implements, even as those of the first humans. They were also painstakingly skilled in hunting and able to not only send a group for the hunt but also process the animal for meat, clothing, and other purposes. However, the more the evidence piled up, the more the question arose, albeit strangely, if their range was really limited to Europe, then why were their traces found so many miles away? The digs in the Middle East not only scrapped but also shocked the comfortable concept of the Neanderthals being an exclusively European species. The fossils found in the Levant in today's Israel and Iraq demonstrated that these primitive men had previously cohabited with modern Homo sapiens, the remains of the two species lying in the same soil talked of living together and communicating. Moreover, the story of the European caveman began to disintegrate when human bones were found to be even farther east, deep in Central Asia. Such discoveries represented the existence of a far more extensive and intertwined population, one that stretched over continents, followed the migration of herds, and melted the climate of the Ice Age world with its varying seasons. The major discovery was not the bones themselves, but rather what the bones had been carrying all this time, ancient DNA. For a long time, the scientists had been dreaming of getting genetic material from fossils. But it was only in the late 20th century that the technology was finally available. The dense formations of teeth and bones contained remnants of Neanderthal DNA for tens of thousands of years, preserved in their very original state. When the researchers eventually examined those fragments, the data not only gave answers to the old questions, but also opened them up for discussion anew. There was one excavating site, however, that changed everything. The Semade loses literally the pit of bones in northern Spain. Within a cave at a great depth, the archaeologists found not just one, but at least 24 individuals whose remains date back to the era of 430,000 years ago. The skeletons were showing early Neanderthal characteristics: strong jaws, thick brows, and facial contours that clearly heralded later typical Neanderthal. But when the researchers took DNA from their bones, it was totally unexpected. The nuclear DNA linked the bones to Neanderthals, which was already anticipated. However, the mitochondrial DNA, which is inherited only from the mother, conveyed a different narrative. It was most similar to that of the enigmatic Denisovans, a long-gone human species that we only know about through a few remains discovered in Siberia, which is thousands of miles away. But to uncover how this shared ancestry began and what really split our species apart, we must travel back to the beginning, to the ancient divide that refused to stay still, the split that wouldn't stay still. If we could rewind time to 500,000 years ago, we would see a world not divided by continents or species, but by possibilities. Somewhere between 500,000 and 600,000 years ago, a population of early humans roamed across Africa and Western Eurasia, a single adaptable lineage that would eventually give rise to several distinct branches of humanity. One of those branches became us Homo sapiens. Another wandered north into colder lands, evolving into what we would later call Neanderthals. But the idea that these two lines split cleanly like a fork in a tree is a convenient illusion, the truth revealed. By DNA is far messier and far more revealing. When scientists first drew the human family tree, they imagined it as a series of tidy divisions. One species splits into two, each following its own path. For Neanderthals and modern humans, that separation was supposed to have marked the point where our stories diverged. Two roads that never crossed again. Yet the ancient genome tells a very different tale. Instead of a clear fork, it shows a braided river where populations separated flowed in parallel for millennia and then met again, blending and reshaping each other in ways that defy simple categories. The oldest DNA samples extracted from ancient human fossils corroborated what could not be determined by bones only. This separation was not an incident, but rather a protracted process lasting thousands of years. The groups gradually separated by means of distance, not through isolation. Climate changes, migrations, and the immense size of the Ice Age terrains, their characteristics slowly started to change. The northerners adapted to cold climates, turning into stocky-bodied, muscular, and wide-nosed people for humidifying icy air. On the other hand, those who stayed close to Africa kept the light, slender frames that are better for heat. 2. Alternatives were there, both very intriguing. The first alternative was that Neanderthals and Denisovans descended from a remote ancestor who gave different genetic lineages. The second one, more daring, was that their ancestors had occurred to be mingling already before any species was completed, to the point of being recognizable. To put it differently, even before the terms Neanderthal and Denisovan were invented, their lineages were interwoven. It was not the case of two distinct beginnings, but one variable continuum. This understanding completely changed the old paradigm. The split was not the termination of a relationship, but the start of an exchange that was to be lasting, one that lasted through hundreds of thousands of years. The world of that period could never be distinctly categorized into us and them. It was a continuum of changing humans, existing on different continents, adapting and reuniting over and over again. But if Neanderthals were part of this restless web, constantly moving and merging, how did they manage to stay connected across such a vast and frozen world, highways of ice? The Ice Age wasn't a frozen, lifeless wasteland. It was a restless, breathing world in motion. Glaciers advanced like slow-grinding giants and then retreated again, carving valleys, damming rivers, and reshaping continents. In this ever-changing landscape, Neanderthals lived not as prisoners of the cold, but as its masters. They followed the rhythm of the ice, moving with herds of mammoth bison and reindeer across lands that today lie buried beneath forests or seas. What looked like an age of isolation was in truth an age of connection. These frozen frontiers became the highways of prehistory, carrying the Neanderthals farther and faster than anyone had imagined. The old view of the Neanderthals painted them as people of Europe alone, fixed in caves while the glaciers ruled the north. But genetic evidence overturned that image completely. When researchers compared DNA from Neanderthals across Eurasia, they discovered not one uniform population, but two distinct branches. One lived in the west, scattered across Europe from Spain to France to Croatia. The other stretched far to the east into the mountains of Siberia. For thousands of years, these groups evolved apart, separated by vast distances and harsh climates. And yet their DNA held traces of each other, as if ancient wanderers had crossed the endless ice to meet and mix again. This discovery broke the theory that Neanderthals were a population that only existed in distant places. Rather, they were a constantly moving community, versatile, strong, and linked by the roots of rock and ice. The glaciers created these roots, and during the warm times they became small passages for whole groups of people to move from one continent to another. When the cold became stronger, they went south into the warm places. When the warm weather returned, they moved north again, hunting and finding new places to live. The result of this was a very complicated population history where groups separated, reunited, and took over one another during the span of tens of thousands of years. One of the major elements making this story so remarkable was the Caucasus Mountains, a rugged region that served as a crossroads between Europe and Asia. The Caucasus Mountains were at the same time a wall and the place through which to pass. By trapping warm-blooded animals and humans, its snowy peaks could last for thousands of years, thereby isolating them just long enough for their DNA to mutate. However, when the glaciers retreated and the valleys became accessible, it turned into a powerful meeting ground, a place of genetic interchange where the East met the West. Modern genetic analysis reveals that the Caucasus was a major center of resurrection and replacement, one where complete Neanderthal lineages could die out and be replaced by fresh ones coming from another direction. Even some Eastern Neanderthals that were considered to have lived and died in complete isolation are shown to have closer ancestry with Europeans than with the local population who lived next to them before. This implies that migration was not the exception. Rather, it was the rule. An impressive case was provided by Chagirskaya Cave, which is in Siberia. In this location, researchers managed to get DNA from a Neanderthal female whose genome was more similar to that of Western Neanderthals from Croatia than to that of the ones who had been living nearby just a few thousand years before her. This discovery was remarkable. It indicated that her progenitors had traversed over the 1,000 meters east up the glaciers and tundra to either replace or mix with the local populations. Long D-distance gene flow thus offers a picture of a non-static species. They were nomads who recognized no borders in the ice. And into that web steps a shadowy cousin whose genes speak louder than their bones, ghost cousins in play. For centuries, the Neanderthals stood alone in our imagination, our strange extinct cousins haunting the cold caves of prehistory. But the Earth had been keeping another secret. In a remote cave in the Alai Mountains of Siberia, scientists unearthed a tiny fragment of bone no larger than a fingernail. At first, it seemed unremarkable, just another fossil among thousands. But when researchers extracted its DNA, the results rewrote human history. This fragment did not belong to a Neanderthal or a modern human. It belonged to someone else entirely. A new branch of humanity now known as the Denisovans. The Denisovans were ghosts in every sense. Unlike Neanderthals who left behind hundreds of fossils and tools, the Denisovans left almost nothing. Just a few teeth, a fragment of jawbone, and bits of bone dust from a single Siberian cave. Yet from those tiny remnants, scientists uncovered a hidden world. Their DNA revealed that Denisovans had once spread across much of Asia, thriving in lands that stretched from the mountains of Siberia to the islands of Southeast Asia. They were not a myth or an anomaly. They were an entire population that had been hiding in plain sight. Their legacy written not in bones but in genes. The Altai Mountains harbored the species in a habitat where ice-cold winds would flow through the valleys. Quite often, the two species were in the same place once, even in the same cave where one was just a time apart from the other. The genetic findings are strong enough to claim that they were in contact many times and even had kids together who got their genes from both sides. In one amazing instance, scientists came across the remains of a little girl with a Neanderthal mom and a Denisovan dad, the first confirmed hybrid among the ancient human species ever found. Her existence was like the mute signal that DNA had been transmitting. The frontiers between these groups were never total. Today we can see the most fascinating outcomes of these meetings. The people from East Asia and Oceania possess a small but notable amount of Denisovan DNA, sometimes even up to 5% of their genetic material. These ancient DNA fragments are not only curious but also involved in the body's processes. One of the genes inherited from Denisovan, for example, allows the human population of the Himalayas to endure the extreme conditions of low oxygen at high elevations. Other genes are related to immunity, fat metabolism, and even how the body utilizes sunlight. These genes are like living evidence that the Denisovans were not gone. Rather, they were the invisible and quiet allies in the making of our modern human being. Denisova's discovery not only put an end to the idea of a linear human evolution, but also redefined it to a complex net of interconnections among different species. This urged the researchers to give up the simplistic notion of isolated chronological species. Today we think of human history in terms of a network of intermixing populations that included Neanderthals in the West, Denisovans in the East, and modern humans emerging from Africa, all meeting, interbreeding and separating again in a complicated dance that decided our common future. The uncovering of each Neanderthal or Denis DNA from a fossil only brings more new twists to that dance. Some of the findings showed that there have been separations for very long periods, and each kind of human had its own way. Others reveal surprising marriages after thousands of years of separation. The prehistoric time was filled with movement, partnerships, and exchanges, a genetic communication that lasted much longer than anyone had imagined. When our ancestors arrived in force, the braid tightened and then began to fray. A legacy inside us. When modern humans began their great migration out of Africa around 60,000 years ago, they were not entering an empty world. Across Europe and Asia, Neanderthals had already made their home. For hundreds of thousands of years, they had endured the bitter winters, hunted the great beasts of the tundra, and raised their families under the glow of a hearth fire. But when Homo sapiens arrived, the balance shifted forever. It wasn't a battle fought with spears and fire. It was a collision of worlds, a merging of bloodlines, and a quiet transformation that would leave its mark on every generation that followed. The archaeological locations scattered across the Middle East are still revealing the first signs of human contact. Neanderthals, along with their sterile species and modern humans, have their remains at the same level of earth in caves that offer magnificent views of the deserts of Israel and the valleys of Iraq. For some time, they inhabited the same areas, had the same hunting trails, and perhaps even shared the same fears. The production of tools reached a point that it was almost impossible to distinguish between the two cultures the quality of the flint knives and the pigments used either for painting or the rituals. All these actions were carried out for the same reasons, and the close resemblance in production techniques indicates that the two races were very much together, watching one another, learning, adjusting, and perhaps even living together. The legend of violent and easy conquest gives way to a more human, quieter, and more realistic picture. The meeting of two tribes, each one recognizing something similar in the other, and the formation of a mixed identity. The genetic evidence backs up what the archaeological finds only hint at. The combining of the gene pools was large. A person who is not of African descent today has a genetic inheritance of about 1 to 2% of Neanderthal DNA, small for each but huge for the whole. The billions of humans have made the fragments of DNA a vast genetic inheritance, one that still affects our biology. When the scientists first began to analyze these fragments in the human genome, they found a fact that was far beyond just historical curiosities left by Neanderthals. They were the survival techniques, the tricks. Neanderthal genes were among other factors that helped our ancestors adapt to the colder and darker climates of Eurasia. Humans later became tougher and overcame the diseases that had been transmitted in different regions. The genes affected not only the tanning and the color of our skin and hair regarding the sun, but also the way our bodies used fat and even our sleep patterns. Therefore, Neanderthals had the wisdom and foresight to make the world ready for us. They had already been through the same adversities for millennia, and when our ancestors mingled with them, we received through DNA the tales of their hardships told in words of silence. Neanderthal DNA has cracked the old myth wide open. Their origin was never a dot on a map. It was a network across ice and steppe shaped by crossings with ghost cousins, and finally with us. They did not just vanish, they merged into our story. If this changed how you see our shared past, like the video, leave a comment and subscribe for more deep dives. And keep watching the next video on your screen for another chapter in the human journey.